everyone, this is Adrian with Sunny Boys, and this is our status equilibrium problem code. And I'm going to walk you through this code and show you how it works and the different equations that we use and how we got them. I will also show the different variables and what they mean. And so basically this whole project is basically being able to apply the principles of statics to evaluate a system of two strings hanging from a ceiling surface connecting at one point and holding the weight of a block. So if you look right here, right next to the code, you see this figure. And this figure, we're actually going to be solving. Let me see. We're actually going to be solving for that tension and this tension. And so these are two strings, and in this figure, we're going to be solving for the tensions. But it's not just the tension, it's actually the max tension in the corresponding lengths that represents it. And what I mean by that is that we're actually going to be alternating this figure, and we're actually going to be creating a range of different lengths, meaning that way will be moving, or this way will be over here, or D will be changing, or vice versa. And with those values being changed, obviously there will be a corresponding max tension that represents what the length of it. And so that's actually what our code is going to be doing. It's actually going to locate the max tension where it happened and output the max value along with the corresponding length. And so if we look over here in our code, we have our mechanics problem, project 2, Sunny Boys, and we're Milton, Adrian, and David. And then right here we have our problem summary, my inputs, other variables, and outputs, and this is all my comments. And if you actually read these comments, you'll be able to figure out what each variable means and basically know what we did overall. But I mean, I'll still walk through it. So we first started with a housekeeping command. So in our housekeeping commands, we have our COC, clear, and close. And we do need our close in there because we are going to be plotting. So yeah, we'll need close. And then, so the first thing is reading the Excel data file into MATLAB, which is the tension data. So that data set is actually right here. So that data set consists of D, W, and length AB. And so these variables are actually going to be inputted. So knowing these values, we're going to be using those values to actually solve for the remaining variables, which is theta, phi, and actually length too, because that will be a missing length. And also, well, tension 1 and tension 2. But yeah, so if we look over here in our code, we have D, W, and L1. And those variables actually correspond with column 1, column 2, and column 3, which is D will be for 16, that will be for 981, and length AB will be for 10. And then we have this X value. So this X variable is actually a range that we created that basically represents the distance from point A to the weight. So what I mean by that is X will be this distance right here. So X will be a range depending on where the weight is kind of located, and we went ahead and started off with 0.25, and we extended that length all the way to length 1. And so we're actually going to be using that range to find the height, the missing length 2, and other variables, which I will mention right now in a little bit. And so then we have H. H is actually the height. So H will be this value right here. So just drawing that line through that big old triangle, you split them up into two triangles. And we actually use Pythagorean theorem to solve for height. And I'll show you right there right now. So if you look right here, we know X right here, and L1 is an input, and then X is the range that we created. So knowing these two values, we actually just plug them into the Pythagorean theorem, and that's how we were able to solve for H, which is the height. And then over here in our code, you have length L2, which is the second length. And so we use the same thing. We use Pythagorean theorem because we know d minus x. Well, if you don't know what d minus x is, then if you go back over here, if x is equal to this and d is the whole thing, well, if you just d minus x, that'll be the remaining of this length basically. So that's dx. So d minus x, sorry. And then, well, we know height, which we just solve for height. And then we just plug them into the Pythagorean theorem again. And that's how we're able to solve for length 2. And then I'll show that later. And then over here we go back to our code. We have this for statement. So this for statement is actually checking for negatives. So what I mean by that is, if you look in our data set right here, we have 3 numbers. So if any one of these numbers is negative, this for statement is actually going to go through it and check and verify that none of those values are negative. If for any reason it is negative, it will issue a warning saying that the data was negative, and it will take the absolute value of it, and the code will continue to run. And then after that, we have this if statement. So this if statement is actually checking to make sure that the length 1 is not greater than length 2, which to make sure that length AB is not greater than length 2. If for any reason it is, it will issue a warning sign again saying that the length is too long, and then it will output a text in the command window saying to input a value less than the corresponding value of D. So meaning, so if in this case, if D is 16, it will say input a value less than 16. And then once you input a correct value, the code will continue to run. You'll get your outputs. So then we have this right here, which is calling on the function. So calling on the function. So our function that we created, it actually takes in the L1, L2, and W, and then it outputs data phi, T1, and T2. T1 and T2 are actually the tensions, which I'll show you right here. So T1 is tension for length 1, and then T2 is the tension for length 2. And so we'll take a look at our function right now. And so this is our function right here. So in our function, we have inputted x again, our range, and if you forgot, x would be this right here, just because you forgot. And then we have theta phi, t1 and t2, and then we have the equations that we use to get those values. And I will show y'all right now what equations we use. So for theta, we actually use SOHCAHTOA. Reason why is because we already know x, and L1 is again our input. So cosine of theta is equal to adjacent over hypotenuse. So if you just plug in x and L1 and take the inverse of cosine, you'll get your theta. And then same thing for a phi, we use SOHCAHTOA as well. So I mean, we know d minus x, and we know length 2. And if I didn't mention, the reason, I mean, I don't know, you might question what is d minus x. Well, if this whole length right here, if this whole length is d, and then this is x, well, d minus x is the missing length. And so that's where we get d minus x. That goes to the equation right here. So then you just plug it in. Then you just plug in those values into the cosine and take the inverse of it, and then you get your phi.